So we had finished this till this part. Do you have any doubt till this in relative motion? Do you have any doubt till this part?
No, sir.
No, sir.
So let's start a new chapter. I've left one section in this part, that is circular motion, which I will define you after work, energy, and power. So next is Newton's law. First is, what do you mean by force? Sabita, tell me. Mariam, what do you mean by force?
The interaction of body which can change the state of the body.
Okay. Anything more?
Force also defines inertia.
Okay. Suppose if you have a body and if you apply any action from backside, it will be termed as push, or from forward, it will be termed as pull. So this push and pull will be termed as any action to given body, which may define three different terms. First, it would be responsible for changing the state of body from rest to motion or from motion to rest. Next is it will be responsible for changing direction. Or third, it would be responsible for changing the configuration of body, that is shape or size. So you can say a force is any action which may bring out these three different changes to a body, that is termed as force. Any action, push or pull, which can cause to change state, that is state of rest or motion, change in configuration, that is shape or size, or direction, then that action is termed as force. Is it clear?
Yes, sir.
Now suppose there is a block which is placed over any surface. And if you apply any external force on this object along this direction, it may be experiencing some forces. First, due to gravity, mg, in downward direction. To balance that gravitational force, there will be a normal reaction provided by this surface against it along this direction. And there will be another force due to roughness of the two surfaces in contact opposite to its motion, that will be called as friction. So mainly a body will have these four different forces acting at any instant. Now on the basis of their magnitude, we can break them into two parts. First is if sum of all forces acting in any coordinate axis is equals to 0. Suppose N equals to mg if external equals to friction. So I can say sum of forces acting on this body is 0. This is termed as balanced force. Now suppose if external force is larger than frictional force, then summation of forces in this condition would not equals to 0. That would be termed as unbalanced force. Is it clear?
Yes, sir.
Arslan, any doubt?
No, sir.
Now, for balanced force, we may define first law as well as third law, or first law or third law will be based on this balanced force. And for unbalanced force, we define just second law. First, write it down to this part. Then I'm starting with first law.
Done, sir.
Done, sir.
Done, sir.
Sufan, you have written.
Yes, sir.
Arslan, okay. So first thing is first law, or it is also termed as law of inertia. Samira, tell me about this. You must have learned in class 9.
Every body continues to be in its state of rest or of uniform motion unless acted upon by an external force.
Oh, good. So we can say every object continues its own state unless acted by any external force. So this is also termed as law of inertia. So first is, what do you mean by inertia? Suppose there is a block which is kept over a table. And if you left undisturbed, this whole thing, this block having tendency to change its state by itself, or it can't change it. So you'll say this block has inability due to which it can't change its state by itself. This tendency or inability of any object is termed as inertia. Is it clear?
Yes, sir.
So inertia is nothing but the inability or tendency of a body so that they can't change their state itself is termed as inertia, and it will depend upon mass of body. So we can say mass is the measure of inertia. Greater the mass of body, it will have greater moment of inertia or more moment of inertia. Greater the mass of body, greater will be its inertia. Now, depending upon body, inertia is of three different types. So we can define types of inertia. First is inertia of rest. If a body is initially at rest, it will tend to be at rest. Second is inertia of motion. If a body is in motion, it will tend to move in uniform direction, uniform motion. And third, inertia of direction. Object will tend to move in straight line always unless acted by any external force to change its direction. So inertia of rest is object will tend to be at rest. Object will tend to be in uniform motion and inertia of direction, object will tend to be in straight path. Is it clear?
Yes, sir.
Sir.
Okay.
Done, sir.
Done, sir.
Arslan, you have written?
Yes, sir. Done.
So we may define inertia in some other sense as the ability of a body which opposes external force so as to continue their own state is termed as inertia. So we may define inertia as the tendency of a body to oppose external force so as to continue their own state is called inertia. Now the next term is linear momentum. Sabita, tell me about this. I'm not asking about its formula. I'm asking about what do you mean by linear momentum? Samaira?
Sir, I know it's formula only.
Okay. Mariam?
Sir, only formula.
Okay. Suppose you have a car which is moving at some velocity v, and there is a heavy truck which is moving at some velocity v. So which of these two terms will require larger force to get stopped? Car or a heavy truck?
Heavy truck.
Good. So this will require larger force to get stopped, and this will require smaller force to get stopped. Now suppose if there is a bullet fired from any gun having mass m, and there is stone having mass m thrown by any one of you. Now tell me which of these two terms will require larger force to get stopped, bullet or stone?
Bullet.
Good. Now in these examples, I have defined you, all are moving body. So if you have to stop them, you need two different terms. First, in this first example, we have smaller mass for car and heavier mass for this particular truck. So we can say a moving body having more mass will have more quantity of motion with it. That's why it will require larger force to get completely stopped. Similarly, in the second part, both objects having same mass, but bullet would have much larger velocity. Stone will have smaller as compared to that. So bullet having very large velocity would have very large amount of motion or quantity of motion contained with it. That's why it will require larger force to get completely stopped. So from this, we can conclude the quantity of motion contained in body would depend upon two factors. First is mass of body, and second is its velocity. This physical quantity is termed as linear momentum. Is it clear?
Yes, sir.
So we can say the physical quantity which defines the quantity of motion contained in a body. Since it will depend upon two factors, that is mass and velocity, that's why it is equals to product of mass and velocity. So P equals to mass times velocity. So in this product, mass is scalar term, but velocity is a vector term. So scalar multiplied by any vector will give you just vector. So it will be vector quantity having SI unit is kg meter per second. Is it clear till this part?
Yes, sir.
Yes, sir.
Safan, any doubt?
No, sir.
Okay, just write it down.
Done, sir.
Done, sir.
Done, sir.
Done, sir.
Now I'm giving you some problems related to this to find change in linear momentum. Suppose there is a wall and this is any horizontal line. A ball having mass m moving with velocity v, so it will have momentum mv, strike on this wall at some angle theta and get reflected back with same velocity at same angle. So we have to find change in linear momentum in this entire process. So how to simplify it? First, break its component while striking this wall with momentum mv. If you break its component with respect to this theta, it will have mv cos theta adjacent to this theta component and mv sin theta perpendicular to it. So this will be termed as initial momentum. On get reflected back, it will move along this direction with momentum mv at inclination theta, due to which it will have one component along this direction as mv cos theta and the other along this direction as mv sin theta. So this will be termed as final or after reflection. Now we have to find change in linear momentum along x-axis and y-axis, for which we have to take coordinate axes. So in first part, change in linear momentum along x-axis. So it will be P final minus P initial. As final momentum along x-axis is mv cos theta, which is in positive direction of x-axis, minus initial momentum is in negative direction of x-axis, so it will be minus of mv cos theta. Minus and minus will become plus, so it will be 2 times of mv cos theta, that is change in linear momentum along x-axis. Is it clear?
Yes, sir.
Similarly, if you find change in linear momentum along y-axis, P final minus P initial, as final momentum along y-axis is mv sin theta, which is in negative direction of y-axis. So it will be minus of mv sin theta minus an initial mv sin theta is also in negative direction of y-axis. So it will be minus of mv sin theta. This minus and this minus will become plus. So you'll get minus of mv sin theta and plus of mv sin theta. These two terms will get cancelled out, so it will be just 0. Is it clear?
Yes, sir.
Just write it down till this part.
Done, sir.
Done, sir.
You all have written?
Yes, sir.
Safan?
Done, sir.
Okay. Sabita, just see in this part, there is a wall on which a ball is striking with some momentum mv at some angle theta with respect to horizontal and get reflected with same angle and having same momentum. So we have to find change in linear momentum in this entire process. So I have broke this two part, that is incident and reflected, initial and final as well. For this initial part, as it is going towards wall, so there will be two components related to this theta. One would be mv cos theta and the other is mv sin theta. Similarly, on get reflected back, you will have two components related to this theta. One is adjacent to this, that will be m cos theta, and other will be m sin theta. Now, depending upon coordinate axes, as momentum is vector quantity, so it would have direction. So first I'm calculating change in linear momentum along x-axis. So it will be P final minus P initial, as final momentum along x-axis is towards positive side. That's why we have plus mv cos theta. And initial momentum is towards negative x-axis. So it will be minus of mv cos theta. So minus and minus will become plus 2 mv cos theta. Is it clear?
Yes, sir.
Okay. Now I'm giving you one more problem related to this. Suppose there is a surface and a ball from this point is allowed to fall on there and will get reflected to this height. So this will be H1 and this will be H2. So we have to find change in linear momentum in this entire process. So how to solve it? Suppose for this initial path or falling down in this direction. At highest point, initial velocity of body will be 0. So it will hit the surface with some velocity v1. So using third equation of motion, we can find v1 square equals to u1 square plus 2gh1. As u1 is 0, so v1 will be root of 2gh1. Is it clear?
Yes, sir.
So this will be initial momentum, and since it is going vertically downward, so it will be negative or it will be in negative y-axis. So linear momentum initial would be mass times v1. On getting rebounded to this height, it will have some initial velocity u2, and at highest point, its velocity would be 0. So using third equation of motion, we can find v square equals to u square minus of 2gh2. As final velocity is 0, so u2 will be equals to root of 2gh2. So this will define you final momentum along y-axis, mass times u. Now, if you want to calculate change in linear momentum during this entire process, so it should be P final minus P initial. As initial momentum is in negative y-axis and final momentum is in positive y-axis, so m times u2 will be in positive minus m times v1 will be in negative. So minus and minus will become plus. If we take out m as common, so you're left with root of 2gh2 plus root of 2gh1 as change in linear momentum during this entire process. Is it clear?
Yes, sir.
So far, any doubt?
Oh, no, sir.
Okay, just write it down.
Done, sir.
Done, sir.
Done, sir.
Sabita, done? A ball of mass 200 gram strikes a wall at 60 degree with velocity 10 meter per second. Find change in linear momentum. Just use the above formula, put the numerical part in that. In this question, we have mass in terms of gram. So we have to first convert it in terms of kg, then put in the above formula. Try to solve these two problems using above two concepts. Mariam, just check your calculation. In first part, we have mass as 200 gram. So divided by 1000, you'll get 200 is equals to 0.2 kg. Velocity of board is 10 meter per second. Angle is 60 degree. Put these values in above formula. Change in linear momentum equals to 2 times mv cos theta in this part, and try to simplify it. Sumaira, check your calculation. Good, Mariam. Good, Safan. Using these value, change in momentum is mass times height of rebounding, height of approaching. Good, Samara. Arslan, send me your answer. Savita,
Yes, sir.
send me your answer.
Yes, sir.
Good, Mariam. Good, Samira. Good, Safan. Good, Sabita. If you put all the values in first part, 2, mass is 0.2, velocity is 10, and cos of 60 degree is 1 by 2. So this 2 and this 2 will cancel out. 0.2 into 10 will be just 2 kg meter per second. Good, Arslan. Similarly, in the second part, we have mass as 0.4 root under 2 g is gravity, which is 10. H2 is 1.8 plus 2 g, H1 is 5. So if you simplify it, 1.8 into 2, it will be 3.6 into 10, that will be 36. Root of it will be 6. 5 into 2, 10 into 10, 100. So it will be just 10. So 10 plus 6, 16 into 0.4, it will be 6.4 kg meter per second. Is it clear to all of you till this part?
Yes, sir.
Sir.
Okay. Now, using this momentum, the next term is second law. Suppose a body having mass m is moving with some velocity v or some velocity u, whether any change would cause in this particular velocity if there will be no force applied on it. So you'll say no, due to law of inertia. Now, suppose there is a force applied on this body, which will be responsible for changing its velocity from u to v. Now, initially, it was moving with some velocity u, so it will have some initial momentum. On applying this force, since velocity of body will change, so it will have momentum m times v. So this change is momentum would be caused by this external force. So we can say the rate of change in linear momentum would be directly proportional to applied external force. Is it clear?
Yes, sir.
So the rate of change in linear momentum is directly proportional to the applied external force. So F is directly proportional to change in linear momentum, change in time. So if you remove this or replace this proportionality constant or proportionality by any constant term K, so it will be delta P divided by delta T. Experimentally, K equals to just 1. So F equals to delta P over delta T. Write it down till this part.
Done, sir.
Done, sir.
Done, sir.
Done, sir.
Okay. Now we have to take instantaneous of this particular term. So f is equals to limit delta t tends to 0 times delta p over delta t. So this whole term is nothing but differentiation of p with respect to time. So it will become dp over dt. Now, as momentum is product of mass times velocity, and I'm assuming that both mass and velocity is variable in this part. So if you differentiate it with respect to time using product rule, suppose you have y equals to fx multiplied by gx. So if you differentiate this phi, which having two different function and related by multiplication, so it will be differentiation of first function multiplied by second plus differentiation of second function multiplied by first. So this is termed as product rule of differentiation. Using this, if we differentiate mass and velocity, so it will be differentiation of mass multiplied by velocity plus differentiation of velocity multiplied by mass using product rule. Is it clear?
Yes, sir.
Now we can say if mass is constant, so differentiation of any constant term will be 0. If you put this term in this above equation, you will get f equals to m times dv over dt. dv over dt is nothing but acceleration. So it will be mass times acceleration equals to applied force. So this formula will be applicable only if mass is constant. Next, if velocity is constant, so differentiation of any constant part will be 0. If you put in the second part, you will get f equals to velocity times dm over dt. So this will be force for variable mass system or changing mass. Like rocket propulsion, moving balloon, and so on. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Done, sir.
Sabita, you have done?
Yes, sir.
Okay. A body of mass 200 gram is moving at 10 meter per second. Acted by 5 Newton force. Find its momentum in 2 seconds. Try to solve these two problems. Safan, just check your calculation. Mariam, any problem while solving?
No, sir. Doing, sir.
In first part, we have mass is equals to 200 gram divided by 1000. So it will be 0.2 kg. As we have formula, force is equals to change in linear momentum over time taken. So we may write it as P final minus P initial divided by T minus 0. Now put the value of each term. Force is 5 equals to P final, we have to calculate. P initial is mass times velocity. Mass is 0.2, velocity is 10 meter per second. Divided by time taken is 2 seconds. Just simplify this. Sabita, just check your calculation. Good, Mariam. Good, Safan. Good, Arslan. In second part, we have momentum as time-dependent function, which is a variable. So we can say F equals to dp over dt. So just differentiate linear momentum, which will be equals to force. And since you have to find time for force to be 0, so put it equals to 0. You will get time. Mariam, check your calculation. Samira, check your calculation. If you simplify it, 2 is in denominator. On moving to the other side, it will become 5 into 2 equals to P final minus P initial. So it will be 2. On moving 2 to the other side, you will get P final is equals to 12 kg meter per second. Good, Mariam. In second question, we have P is equals to T square minus 3T plus 4. If you differentiate it, dp over dt, T square, it will become 2T minus 3, as differentiation of T will be 1, plus 4, which is any constant term. So differentiation of it will be 0. Now equate this expression to the 0. You will get 2t is equals to 3, or t is equals to 3 by 2 seconds. Is it clear to you all?
Yes, sir.
Sabita, any doubt?
No, sir.
You all have written to this part?
Yes, sir.
Now next is unit of force. As we have, force is equals to mass times acceleration for constant mass. We may define first absolute unit. In terms of SI unit, mass equals to 1 kg and acceleration equals to 1 meter per second square. So if you put these two terms in this part, you will get force as 1 Newton. So it will be 1 kg meter per second square in terms of SI unit. In terms of CGS unit, mass is 1 gram, acceleration will be 1 centimeter per second square. So force is termed as 1 dyne, which is equals to 1 gram centimeter per second square. So this is in terms of CGS unit. Now there is relation between SI unit and CGS unit as 1 Newton equals to 10 raised to the power 5 dyne. Is it clear?
Yes, sir.
Arslan, any doubt? Okay. Next is gravitational unit. If mass is equals to 1 kg and acceleration is g, for which value would be 9.8 meter per second square or 10 meter per second squared. So it will be termed as 1 kg force or 1 kg weight and should be equals to 9.8 Newton in terms of SI unit. Next is if mass is 1 gram, this is gram, and acceleration is gravity, which will be in terms of centimeter as 980 centimeter per second square. So it will be 1 gram force or 1 gram weight equals to 980 dyne. So this will be CGS unit. Is it clear? So these are some units of force. Just write it down.
Done, sir.
Done, sir.
Done, sir.
Two forces, 1.5 kiloweight and 2 kiloweight, acts along x-axis and y-axis respectively on a body having mass 5 kg. Find net acceleration. First, try to convert forces in terms of Newton. Take the value of G to be 10 meter per second square here. Try to solve. In this part, we have Fx is equals to 1.8 kiloweight. So this will be in terms of gravitational unit. So if you have to convert in terms of absolute unit, just multiply it by the value of gravity. So it will be multiplied by 10. So it will become 15 Newton. Similarly, Fy will be 2 kiloweight multiplied by 10. So it will be 20 Newton. Now Fx and Fy are component of force. So you have to calculate net force acting on this particular object. So using concept of vector, it will be root of x component squared, y component squared. Just put the value of Fx and Fy. You will get F or resultant force. Now using second law, F equals to mass times acceleration, you will get value of net acceleration. Is it clear?
Yes.
Okay, try to solve. Good, Safan. Good, Samira. Good, Maria. If you put the value of fx and fy in this expression, fx is 15 squared, fy is 20 squared, root under. 15 square is 225 and 20 square is 400. So it will be 625 or it will be just 25 Newton. So acceleration will be force divided by mass. So it will be 25 by 5 as 5 meter per second squared. Good, Arslan. Okay, next term is impulse. Suppose there is a nail and a hammer is applied over it to inject it into surface. So a very large force applied on this particular object and time of contact between them would be very small. This quantity is termed as impulse. So you'll say when a large force is applied on a body for short time, so the product of force and time will be termed as linear impulse. So it is denoted by I, which is equals to force times time. As unit of force is Newton and time is second, so it will be Newton second. And since force is a vector quantity, which is multiplied by any scalar time, so it will be a vector quantity. Now I'm defining a relation with respect to linear momentum. As force equals to delta P divided by delta T. So if you move delta T to the other side, you will get F times delta T is equals to delta P, or change in linear momentum. And F delta T is nothing but impulse. So it will be equals to delta P, that is P final minus P initial. So we can say impulse is nothing but change in linear momentum. So this is also termed as impulse momentum theorem. Impulse is equals to change in linear momentum, or it will be termed as impulse momentum theorem. Now, in this above part, we have impulse is equals to force into time. So if you draw a curve related to force and time, for a large force acting on a body for short time, the area under the graph will define you impulse. So impulse equals to area under force time graph. Is it clear to you all to this part?
Yes, sir.
Sabita, any doubt?
No, sir.
Okay.
Done, sir.
Done, sir.
Arslan, you have written? Okay. Now I'm giving you a problem related to this. Find impulse. if mass of body is 2 kg. I'm giving you a hint how to simplify it. Impulse, in one sense, it will be equals to force into time. So with respect to graph, it will be equals to area under force times graph. But in this part, we have graph in terms of x versus t, that is position and time. So we have to find change in impulse at t is equals to 2 seconds, let's say. So there is another relation to find impulse, which is equals to change in linear momentum. And linear momentum equals to mass times velocity. And using the graph of displacement time graph, we can find velocity. So we have to use this relationship. Is it clear?
Sir, could you explain again?
Since we have two different formula to find impulse, first one is impulse is equals to force into time. And in terms of graph, it will be equals to area under force times graph. But in this part, we have x versus t graph, that is displacement versus time graph. So there is another relation to find impulse using impulse momentum theorem. It will be equals to change in linear momentum at that moment. So we have displacement time graph. So in last chapter, we have defined slope of displacement time graph will define you velocity. So if you find slope at this instant, or at this instant, since it is a straight line, so slope of every point will be same. Slope is equals to nothing but y2 minus y1 divided by x2 minus x1. So let's say initial velocity while going will be x2 minus x1 divided by t2 minus t1. If you put the coordinate, x2 is 4, x1 is 0, t2 is 2, and t1 is 0. So you will get 2 meters per second. Is it clear?
Yes.
Similarly, for final term, while going along this direction, this point will behave as final term and this will behave as initial term. So to get final, use x2 minus x1. So x2 will be 0, x1 will be 4, divide by t2, 4, and t1 is 2. So you will get minus of 2 meters per second. Is it clear? Now, at 2 seconds, at this sharp end, this particular line at a very small, infinitely small change towards left side, it will have a slope along this direction, which will be Vi. And at very first moment along the right of it, there will be slope along this direction, which will be defined by Vf. So from this, we can write P initial is mass times of Pi. Mass is 2 kg and initial velocity is 2 meters per second. So it will be 4 kg meter per second. Similarly, Pf equals to mass times Vf. Mass is 2 and velocity is minus 2. So it will be minus of 4 kg meter per second. Is it clear to everyone how I have just calculated Vi and Vf?
Yes, sir.
Arslan? Safan, is it clear?
Yes, sir.
Okay. Now, according to the above theorem, as impulse equals to P final minus P initial. If you put, you will get P final is -4, P initial is +4, so it will be minus of 8 Newton second. Sabita, is it clear?
Yes, sir.
Okay, just write it down.
Then, sir.
Done, sir.
Answer.
Find impulse related by this graph. So in this part, we have force versus time curve, and there is a relation between impulse and force time graph. You'll say impulse equals to area under force time graph. So anyone please tell me how to calculate the area of this particular curve? I defined you in third chapter in graph how to calculate area of any curve in physics.
Integration.
No. I've given a formula. For any curve, we just use area equals to pi times r1 into r2. But in this part, we have a curve like half circle. So area will be pi r1 r2 divided by 2, in which r1 will be radius along x-axis and r2 will be radius along y-axis. So from this point to this point is T naught, which is behaving as diameter of this curve part. So R1 will be T naught over 2. And similarly, if you draw a line from this point to this point, taking this as center, so this F naught will behave as R2. Is it clear? Samara, Any doubt?
No, sir.
Now, since this particular curve is behaving as semicircle, so in physics, area of circle is defined as pi r1 into r2. R1 will be radius along x coordinate, and r2 will be radius along y coordinate. So you'll get pi r1 into r2 over 2. So pi by 2, r1 is t naught by 2 and r2 is f naught. So it is pi times f naught into t naught divided by 4 as impulse related to this curve. Safan, is it clear?
Yes, sir.
Okay.
Done, sir.
Done, sir.
You all have written? Safan? Sabita?
Done, sir.
Okay. Since impulse is related as force and time as area under force time graph, and since in this particular curve or for any curve in physics, we just use area equals to pi times r1 into r2. You must have learned in mathematics, area of circle is pi times r square. But in physics, we use r square as r1 into r2 to define coordinate along x-axis as well as y-axis both. Is it clear?
Yes, sir.
Yes, sir.
Sabita? Okay,
Yes, sir.
that's why I've taken r1 radius along x-axis. Since this t naught, which is behaving as diameter of this particular curve, so r1 will be half of diameter, so it will be t naught over 2, and f naught is behaving as radius along y-axis. Okay, so this is all about first law, second law, and all of linear momentum concept. So let's stop here. From next class, I will define you third law and all problems related to them. That is about normal reaction, tension, pulley problem, and so on. Okay?
Okay, sir.
Okay then.
Thank you,
Thank
sir.
you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.